is going to be about polynomials and how to add and subtract them. But before we talk about polynomials, first we're going to have to talk about monomials. And so the definition of a monomial is right here. I'll read it to you and then we'll sort of just look at what that actually means. It says monomial is a number, variable, or product of numbers and variables raised to natural number power. So what does that mean? Well, you know what a number is, right? Like 1, 5, 11, it's just some number. A variable is most likely going to be a letter, right? Like X, Y, or Z, or anything like that. And then it says, or a product of numbers and variables. Remember, a product is just indicating multiplication. So it's basically saying when you have a number and a variable multiplied by each other. And then it says here, raised to a natural number power. Natural numbers, remember, are just whole numbers that are positive. 1, 2, 3, 4, etc. And so now that we've broken down the definition, we can take a look at some examples of what monomials are. Okay, so let's take a look at some examples of monomials. Remember we said they're going to be either a number or a variable or a product of number and a variable to a positive whole number power, right? So over here, -3, that is a monomial because it's just a number, right? -3 is just a number, so that's good. Over here we have xy squared. So this is a product of two variables. They're two variables multiplied by each other, right? That's fine. And we have a whole number that's positive for our power, right? The power on the y. This is y to the second power. So that's cool, that's a monomial. Over here, 5a squared. This is a number, this is a variable, they're being multiplied. So that's a product of a number and a variable. And then the power here on the a is 2, that's also a whole number that's positive. Over here we have -z cubed. That's also a monomial. Just, if you think about it, there's like a -1 here, right? Times z cubed, and the third power is still positive and whole. And then over here, -1/2 xy cubed. Same thing here. This is just a product of a number, a variable, and a variable, and this variable is to the third power. So these are just examples of what monomials could be. Okay, now I want to go through some examples showing you something that's not a monomial compared to something that is. So over here we have 5 plus x, and that's not a monomial because we have addition here, right? We said monomial is when you have, sure, a number and a variable, but it's when you have a product of them. This is when you're adding them. This is a sum of a number and a variable. So this is actually not a monomial. Whereas over here, still the same number, same variable, they're being multiplied to each other, right? There's like a multiplication right there. So this is a monomial. Okay, looking at another example. This one right here says 3x squared, and according to our rules, that is a monomial, right? That's just a product of the number 3, the variable x, and the x is to the second power. This 2 is a whole number that's positive, so that's fine. Over here, though, it's the same thing except this is x to the -2 power. So according to us, we're saying that's not a monomial because this power up here, this exponent, is negative, right? That's -2, and we don't want that. We just want it to be a positive whole number. Over here, we have 3x to the 0.25 power. So the exponent 0.25 is not a whole number, so that means this is not a monomial either. So neither of these ones are monomials. Okay, so let's look at this one. It says 3 over x, right? And so would this be a monomial? Well, this is 3 divided by x. This is not a product, right? You could say technically this is a product between 3 and 1 over x or something, but this is not a monomial, and let me show you another way you can see why. 3 over x is the same thing as 3 times x to the -1, right? Because x to the -1 is equal to 1 over x, right? So, 1 over x to the 1 if you want to be careful there. So, since this is a negative exponent, that's why this is not a monomial, so this one is not a monomial. Okay, now what I want to talk about is the degree of a monomial. So when I say degree, what I mean is the sum of all the exponents on the variables for that monomial. And so that might sound confusing. Let me just show you what I mean. So basically you're just going to look for the variables, check what exponent they have, and then add all those exponents up for that one monomial. So let's start with 2x. The variable here is the x, right? The 2 is the number, the x is the variable, And so what is the exponent on this x? Well, there's nothing up here, but remember, if there's nothing, that just means there's a 1, right? So, and since this is the only variable, this is going to be your degree for this monomial right here. The degree of 2x is just 1. So let's look at this example. -5. There is no variable here. So for this one, the degree is actually just 0. But there's another way to think about it. You could think about this like being -5 times some other variable. Let's just call it x again, to the 0 power. Because remember, x to the 0 power equals 1. So -5 is the same thing as -5 times x to the 0. And that would indicate the degree of this monomial. Over here we have 6a cubed times b. And so with there's two variables here right now, a and b. So the exponents on them, remember b is just b to the 1, same thing. The exponents are 3 and 1, so to get the degree, you add those up. So that's going to be 3 plus 1 equals 4. So the degree of this monomial is 4. Okay, over here, two variables again. Both of them have a 1. So the degree of this monomial is 1 plus 1, which is just 2. Alright, last one right here. This says 7y cubed. There's only one variable here. The power on it is a 3, right? That's the exponent. So we don't have to add up the degree. Sorry, we don't have to add up the exponents because there's only one variable. So we're just left with a degree of 3. So that's what the degree of a monomial is. Now let's look at the coefficient of a monomial. So the coefficient is just basically the number being multiplied to the variable. It's basically just the number of your monomial. So for 6x, the coefficient is just 6, right? I'll use a red marker. For 32, the number here in this monomial is just 32, right? So that's the coefficient. And then for negative xy, the coefficient here is actually the -1, because it's -1 times xy, right? Even if it just says negative xy, it's the same thing as saying -1 times xy. So the coefficient of here is just -1. So it's just the number of your monomial. Now that we're done talking about monomials, we can talk about what a polynomial is. So a polynomial is a monomial or the sum of two or more monomials. And remember, when I say sum here, that means addition, right? But also remember that subtraction is the same thing as adding the opposite. So really this could say that a polynomial is a monomial or the addition or subtraction of two or more monomials. And so let's take a look at some examples. So right here we have -2x. That's just a plain monomial, right? We looked at that earlier. We have 3x plus 1. This is, let me actually tell you one more thing. All of the monomials within a polynomial are a term, right? And so, the amount of monomials that you have in a polynomial tells you how many terms you have, basically. And so naturally, terms are going to be separated by pluses and minuses, right? Because if they're just multiplication in between, that's still part of your one monomial, right? So it's up until you get to a plus sign or a minus sign where you're separating two terms. So now that I've said that, remember this one is just a monomial, which is also a polynomial. This one here, we have a 3x and a 1, and they're being added, right? This is two monomials, and that means that this polynomial has two terms. Over here, we've got this 4y squared, right, minus this y, plus this 7. So this is a polynomial with 3 terms. Over here, we've got x to the 5th minus 3x to the 3rd plus x minus 7, right? So this is going to be 4 monomials within this polynomial, and so this is a polynomial with 4 terms. And then, so also, keep in mind that, it might be good to know that a polynomial with 2 terms is often referred to as a binomial. One with 3 terms is often referred to as a trinomial. Okay, so now, just before we talk about adding and subtracting polynomials, first we've got to talk really quick about what like terms are. And so, like terms are when you have a monomial and they have the same variables to the same powers, same exponents on those same variables. And so, let's take a look over here. We have 2 monomials, right? we have 5x squared times y, and then negative 2x squared y. So you might notice that for both of these, this part is the same, right? So remember we said for like terms we want them to have the same variables to the same powers. So here the variables are both x and y. So that's a check, right? And then the power on the x is a 2, and the power on the y is a 1, right? Same thing over here. The exponent on this x is a 2. Over here, it's a 1, right? So because all the variables are the same and they're all raised to the same powers, that means these two monomials are called like terms. And what that means is basically that just means that we're allowed to add them up or subtract them. So if I wanted to add these two monomials together, right, 5x squared y plus negative 2x squared y, all I would do is I'd basically just add up the coefficients. So 5 plus negative 2 is 3, right? So I would get over here 3x squared y. And so another way to think about this is this x squared y is sort of like like what defines this monomial, right? Like, you know, you have 5 of these x squared y's. And then you're saying over here, we're saying plus minus, but you could say you're minusing 2 of those x squared y's, right? So if you have like a basket of x squared y's, and you have 5 of them in there, and you take out 2, you're going to have 3 left, right? So this is sort of like an identity of this monomial, is the variables that are involved in it. But if you have, you know, say you have 5x squared y's, and you try to add 3 x's, you know, you have a basket of x squared y's, and you try to add x's, you're not going to come out to 8 x squared y's, right? These don't really match with each other. You could think about it like if x squared y was like an apple, and x was like a banana, you know. If you had 5 apples, you take away 2 apples, you have 3. But if you have 5 apples and you add 3 bananas, you're not going to have 8 apples, right? You're just going to have 5 apples and 3 bananas. So that's really the idea behind like terms.